Hi, everybody. So today's quote, sometimes the greatest gift you can give another person is to simply include them. Let's go back and refresh our memories on how to write an equation of a line. So there are several different types of equations of lines. I actually want you to write it in slope-intercept form. That's y equals mx plus b. So here are your 2 points, and the way you do it, if you want to pause the video and try it on your own first, that would be fine. If not, you can watch, is to find the slope. That's the first step that I usually do. And the slope is y2 minus y1 over x2 minus x1. It doesn't matter which point you label as 1 and which point you label as 2. So if you had done it opposite, you would have still gotten the same slope. So our equation y equals mx plus b, we need to find the slope, which is m, and the b, the beginning value, or the y-intercept. So what we know right now is the slope. I'm plugging that in for m. Um, it looks like I have 3 unknown variables, but actually I'm only trying to solve for b. I already know what x and y is. It's either going to be 3, -1 or -3, 5. It doesn't matter which point you pick, but let's go ahead and fill in that x and y value and now solve for b. -1 times -3 is a positive 3. You wanted to subtract that from both sides, so you end up getting b equals 2. And the equation then is y equals -1x, or just -x plus 2. And here's what the graph looks like. Okay, here's one for you to try. We have 2 points, 3, 1 and -5, 1. You can pause the video and try to write the equation of this line. All right, again, first try to find the slope. So subtract the second y value from the first and the second x value from the first. And you get 0 over 8, which is a number. 0 over 8 is 0, not undefined. Had it been flipped, 8 over 0, that would have been undefined, but this is slope 0. So slope 0, that means it's not increasing or decreasing at all. Here's my 2 points. Here's the equation, or sorry, here's the graph. So what do you think the equation is? It's going to be y equals 1. The slope is 0. The only equation is y equals 1. Okay, so hopefully you know, or it refreshed your memory on how to write equation of lines. Okay, here's something that is pretty challenging for all Algebra 2 students, and they're the properties. So basically what we want to do is describe the graph that we graphed. So we have domain, range, increasing, decreasing. There's a whole bunch of them. I'm going to go through these with you right now. This is the graph of y equals x squared. So the first one is domain. And if I ever quiz you, if I quiz you on properties, I will ask for the property. I won't just have you memorize all these properties. I'm going to actually tell you which properties I want. So the domain. The domain are all possible x values. Now let's take a look at the equation y equals x squared. Can I plug in 0? Sure, 0 squared is 0. Can I plug in 2, 3, 5, a million? I can plug in any positive number. They all work. Can I plug in negative numbers like -1? Well, -1 squared is +1. -3 squared is +9. -100 squared is also a big number. So actually, all real numbers work. So the way we're going to write it in Math Shortcut is this: -infinity to infinity. So the domain, the x values, are all real numbers, or as we write in math, from -infinity to infinity. And those are going to be parentheses, not brackets. I'll talk about that a little bit later. All right, the range now are not all real numbers. The range are all possible y values in this case. So if I look at the graph, it looks like I can get 0. If I plug in 0, I get 0 back out. If I plug in 1, I'll get a value back out. If I plug in 2, I should get a y value back out. So I can get any positive y values out. If I look at the graph, though, it doesn't look like I can get any negative values. Because everything's squared, so everything's going to turn positive no matter what value I put in there. So I can get everything that's positive, including 0. Okay, so when I include a number, I'm going to put a bracket. If I'm not including it, it's going to be a parenthesis. Infinity, I can never actually get to infinity. Infinity is not a number, so that's why we always have a parenthesis on infinity. Okay, increasing, and let me talk about increasing and decreasing at the same time. Basically, what I'm saying is, what are the y values doing? Like, are they increasing or are they decreasing? As the x values increase, that is going from left to right. So when we read a graph, we always read the graph from left to right. So we're starting off at negative infinity and working our way up all the way to positive infinity. So what is this graph doing? So let me take a look from -5, -4, -3, -2, -1, 0. Graph, the y values, when I say the graph, I mean the y values, are decreasing. But once I get to 0, the graph starts increasing, or the y values start increasing. From 0 to 1, the y values increase. From 1 to 2, the y values are increasing. So increasing are from 0 to infinity, and decreasing from negative infinity to 0. It's important that when you write it in these brackets or the parentheses that they're in order from the smallest to biggest. So for decreasing, you wouldn't want to say from 0 to negative infinity because negative infinity is obviously smaller than 0. So it's always in order, negative infinity to 0. The x-intercepts, sometimes I'll refer to them as roots or zeros. Hopefully you can see that it's 0, 0. Same thing as the y-intercept. And two more behaviors right now. First is symmetry. So symmetry is where is the graph the same? And there's two things. There's point symmetry, which I'll talk about later, and line symmetry. This one, y equals x squared, has a line symmetry. If I draw this line right here, the blue one, it's symmetrical on both sides. So I'd have to write line symmetry. And since I said it's a line, I need to write the equation of the line. The equation of any vertical line is x equals a number. In this case, it's 0. X equals 0. All right, and one more for now. The end behavior. It looks like the graph stops. Actually, there we go. We're going to put some arrows on it. The graph doesn't stop. It goes on and on forever. So how can you talk about end behavior when the graph actually doesn't stop? So we're just talking about what happens when x gets very, very, very big. And in math, we say as x gets very, very big, that arrow means as x approaches infinity. So what's happening to the y value? As x approaches infinity, y is approaching what? Well, if x gets bigger, like 5, 10, 100, a million, 2 millions, a billion, whatever. As x gets bigger and bigger and bigger, guess what? The y value is getting bigger and bigger too. So as x approaches infinity, y is approaching infinity. All right, let's do the other end. So when x is very, very small. So as x approaches negative infinity, y is approaching, what is it approaching? Infinity. Y is also getting very, very big. Okay, there's a couple more properties. For now, all I really want to talk about is concavity. So there's concave up and concave down. And those are the two I want to discuss right now. Concave up, here's an example of concave up. And the entire graph is actually concave up. So we're going to have to say it's concave up from negative infinity to infinity. Here's another graph. This one's concave up, and this one concave up from negative infinity to 0. So basically I'm telling you that the y values form that cup up shape. Okay, so it could hold water, kind of. And so when it's shaped more like a up, it's concave up. And when it's shaped upside down, it's concave down. I'm telling you that the graph is concave up. You're telling me what x values will make this concave up or down. Here's one more that's concave up. It looks almost like a straight line, but it's not. It's curved slightly. This is also concave up from 0 to infinity. Okay, here's one that's concave down. And obviously, the entire graph is concave down from negative infinity to infinity. Here's another one. concave down. So the basic shape is upside down. This is from 0 to infinity. And here is the last graph that I want to show you. This looks like it has two parts. One part looks like it's concave down, and the other part looks like it's concave up. So where is it concave down? From negative infinity to probably close to 0. I don't see the entire graph, but I know that this graph is 1 over x, and it does approach 0 there. And this one is concave up from 0 to infinity. Okay, so remember your order inside the parentheses, it has to be from the smallest to the biggest. We always read the graph from left to right. Okay, let's practice one more. I know that this is very confusing, but hopefully with a lot of practice, you'll get it. Okay, here is the graph. I put arrows on it so that we won't get confused. Hopefully you know that this is the graph of y equals x to the negative 2, or sometimes we'll write it as 1 over x squared. So the properties, domain. Let's think about the possible x values. I could plug in negative 100, negative 4, negative 2, negative 1. All those I can plug in. So any negative number works. I can plug in any positive number, like a fourth, an eighth, 500. All those work, but there's one number that doesn't work, and that is 0. I can't have 1 over 0 squared. You can't have 0 in the denominator. So when I write my domain, it's all real numbers except 0. Right now we're going to write it from negative infinity to 0, and then again from 0 to infinity. The range. Even though there are two parts to this graph, the range is there's just one part. I can get anything from above 0. I actually can't get 0, right? Because there's no way I can get 0 out. So notice how I write the range here. On the last one, I had a bracket on 0 because 0 was an answer. And this time it's just the parentheses because I can get anything above 0. Okay, where is this graph increasing? Well, if I'm reading the graph from left to right, it first starts increasing. So from negative infinity to 0, it's increasing. And then it jumps over to the right-hand side and it starts decreasing. So decreasing is from 0 to infinity. X-intercepts, we already talked about. 0 is not a possibility. I can't plug in 0, so there are no x-intercepts, no roots, no zeros. The y-intercepts, I can't get 0 out. So there are, again, no y-intercepts. Let's talk about symmetry next. Symmetry, where is it the same? Again, another line symmetry. If I draw this line up here, x equals 0, the graph would be symmetrical, like a mirror image of each other. Okay, end behavior. There's 4 arrows here. But when we talk end behavior, we're only talking about the ends. So when x gets very, very, very small, like negative infinity, and when x gets very, very big, like positive infinity. The other 2 arrows, the ones that are closer to 0, I'm just going to call them other behaviors, and we'll talk about that later. So for now, when x gets very, very big, like think of 100, it would be 1 over 100 squared, or 1,000, 1 over 1,000 squared. And when x gets very, very, very big, what's y getting? It's getting smaller and smaller and smaller, but not negative. So y is going to be approaching 0. Okay, let's talk about the other end. When x gets very, very, very small, x is getting approaching negative infinity. Y is approaching, again, 0. Okay, since there's 2 parts to this graph, we're going to have to describe the concavity in 2 parts. So on the left-hand side, from negative infinity to 0, it is concave up. And on the right-hand side, from 0 to infinity, it is also concave up. So the way we write it is it's concave up from negative infinity to 0 and 0 to infinity. I know this is challenging, but hopefully with some practice, you'll be able to get it.